Okay, so we're on number 4, and there's only 4 through 7, so these should take us not very long to do. We just have to pick out the important pieces of information, like knowing whether we're going to have a growth or a decay, and then how to set up and solve the equation. Number 4 says, China's one-child policy was implemented in 1978 with the goal of reducing China's population to 700 million by the year 2050. On average, the population has been decreasing. Okay, so that's important words. Decreasing about 0.5% per year. If China's population was 1,200 million in the year 2000, will the population reach the goal by 2050? How much over or how much under the goal will the population be? So the goal of instituting this one-child policy was to try and limit the population, or to make sure that the population wasn't going to explode any more than it already has. Because it says decreasing, this is going to be a decay. And because it's a decay, we have to do 1 minus. Now, this is 0.5%. So again, if you're confused about how to handle 0.5%, we're going to do 0.5 divided by 100. And that's going to give you your decimal that you need. Okay, so 0.5% is 0.005. So that's going to go here. And we have to subtract it from 1 because it's a decay. And when we do that, 1 minus 0.005, this is going to give us a model. Our growth factor, our remaining part, is 0.995. This is what is going in the parentheses. That's going to be our growth factor. So it's not quite 100%. It's a little less than 100%. So it's still going to climb, but not at 100% rate. The next thing is, where is our original population? So we're not looking at the 700 million. We're looking at the 1,200 million in the year 2000. This is our barometer to go by. Okay, so we're going to take our 1,200 million, because this is where we were in 2000. Knowing that it's in millions, we're going to keep this as our growth factor. And since this was in the year 2000, and we want to know what's going to happen in 2050, that time frame that passes is a 50-year span. A 50-year span means that that's going to be our exponent. So again, whatever number we get, this is going to be in millions. And so it's going to be a big one, I think. 1,200 with a 0.995 as the growth factor. And then we are going to raise this to the 50th power because we want what's going to be after 50 years. And we are at 933.975 million people. 933.975 million people. That's what according to the decrease per year, and knowing that we're starting at 1,200 million in 2000, 50 years down the line, keeping that same trend, this is what it's going to be. So the question is, how much over or under the goal will the population be? Well, what was the goal supposed to be? They wanted to reduce China's population to 700 million. This is what they wanted. That was the goal. So the goal was 700 million. What they're really going to hit is 933.975 million. So we are very over the goal by, and to find out, we have to take our 933.975 and subtract off 700. So that's going to give us 233.975 million people. Missed the mark by over 200 million. Crazy. Number 5 is written a little strange, so I want to make sure that you understand how to do it. It says a mutated cell is undergoing mitosis every hour, which means that the number of cells is increasing by 100% every hour. When you increase by 100%, first of all, this is a growth. A growth is going to be 1 plus, and 100%, if you take 100 and divide by 100, you're going to get 1. So the growth factor is actually 2. It's doubling. That's what that means. 1 turns to 2. That's what happens during mitosis. And this is happening every hour. Starting from the single starting cell. So this means that we are starting with 1 cell to begin with. And we are doubling because mitosis means we're doubling every hour. How many cells will there be after 1 day? Well, the thing is, how many hours are in a day? Because this is happening every hour and they're asking for 1 day. So we have to do a conversion. There's 24 hours in 1 day. So we need to put this to its 24th power, because there's going to be 24 cycles of that. If it's happening every hour after 1 day is over, oops, 2 raised to the 24. Ooh, Nelly. 1, ooh, 6, 7, 7, 7, 2, 1, 6. Now I want to say this number properly. I have to put my commas in. 16,777,216 cells. So 1 cell turns to 16 million cells after 1 day. If it doubles, that's what increasing by 100 means. It's growing by 100%. And that's from a single cell. Number 6, a rare painting is appreciating. Appreciate means that it is growing. This is a growth at the rate of 15% every 10 years. Now we're going to hold on to that thought for a minute, but growth means 1 plus 15%. You're going to take 15 divided by 100, so that's 0.15. So your growth rate is going to be 1.15. It's currently valued at $750,000. So that goes out here. This is our what we know right now. And we want to know what it's going to be worth in 50 years. 50 years. That's not going here because this growth rate is happening every 10 years. So what we have to do is take our 50 and divide it by 10, because that's going to be our number of cycles. So every 10 years it's happening, and it's happening over 50 years. That means that our exponent is going to be 5. So we're going to take 750,000 times 1.15, and we're going to raise it to the 5th power, because that's how many cycles of appreciation it will be. So 750,000 times 1.15, and we're raising that to the 5th power because we're doing 5 cycles. And this is going to be worth, hold on to your hats, here it is, 1508517.89, and commonly known as $1,508,517.89. So that $750,000 painting is going to be worth $1.5 million in a span of 50 years. That's why people have heirlooms as, art and artifacts as heirlooms, because they do increase over time. Okay, so it says, by making a simple change to the growth equation, we can figure out how much a painting in number 6 was worth 20 years ago. So I want to talk about that just for a second. When you're trying to figure out what's happened in the past, this is past happenings. This is talking about the time. Past happens in time. So which part of the equation should become negative? That would be the exponent, because the exponent is the one that deals with time. Now we want to know what the value of the painting 20 years ago is. So here's the thing. These are happening in 10-year cycles, but we want 20 years ago. So we're going to take a negative 20, because we want ago, that's in the past, and we're going to divide it by 10, because that's the number of years it takes to go through the cycle. So this is going to be our exponent. Our exponent is going to end up becoming negative 2. So if I take 750,000 at 1.15%, and I want to know what this was 20 years ago, I'm going to put negative 2 in for my exponent, because I'm trying to figure out 2 cycles ago, and that's going to be less, because this is I'm going back in time, so it should be less than the 750. So I'm doing 750,000 times 1.15, but I want to know what was it worth 20 years ago. And look at that. This is how much it grew. Oh, I'm trying to get it so that the light isn't in it. There it is. You've got $567,107.75. So this painting went from 20 years ago. Look at this. This was 20 years ago. 500,000 or 567,000. And then if we fast forward 50 years from now, so this would be 70 years later, you're up to 1.5 million. So it actually gained almost $1 million in value over the span of 70 years. All right, thanks for listening. We're going to move on to the book now. This should go nice and fast. These were our warm up and get through the problems, understanding growth and decay, and looking at a graph. And now we are ready to rock and roll.